So for our Wash U Solar Decathlon team and for our house, we have 4 different precasters that are providing the various components, structural components of the house. One is St. Louis Prestress, and they are providing the outriggers and footings, which support the main part of the house, and they're also providing the roof panels. Duquesne out of Chicago is providing our floor panels, and Gate out of Tennessee is providing our wall panels. And then a company out of Illinois, also, Weezer Concrete, is providing our vertical and horizontal gutters, which allows for rainwater to collect and be used in our vertical planters.
So Crete House has quite a few different concrete panels. We have footings, which are made of precast concrete. They have structural rebar in them and are about 30 inches wide by 22 feet long, just blocks of concrete that the building sets on. On top of that, we have our precast floor slabs. The floor slabs are made with sandwich panels, which means they have concrete on the underside, insulation in the middle, and another concrete layer on the top side. That top layer of concrete has a polished finish on it so that we get a nice smooth floor condition. On the edges of the panels we have recesses so that we can cover the joints and make a really smooth transition from one panel to the next. The 2 pieces of concrete that make up that sandwich panel are connected with a truss that runs between the 2 that provides structural rigidity and connection between the panels itself. And those panels are connected through the bottom layer of concrete called a withe to the footing via bolted connection. Also sitting on the footing on the outside of the floors are the wall panels. The wall panels are made of 3 layers as well, also a sandwich panel. We have a 4-inch interior layer of structural concrete that's reinforced with rebar. There's a 5-inch layer of foam outboard of that, and the exterior layer is 1.25 inches of an ultra high performance concrete called ductile. That material is very strong. It's almost 18,000 psi, and it is fiber reinforced with fibers within the mix, so there's no need for conventional reinforcing such as rebar. All 3 of those layers are tied together with thermomass connectors, which are essentially little fiberglass rods that are embedded in both layers of concrete as they're poured and connect through the insulation, the fiberglass being not as conductive as, say, a metal or a steel type of connector between the layers. On top of our walls, we have our roof. Our roof supported by a steel angle that allows it to sit within the walls, which gives us a full 9-foot ceiling height and allows us to have full height windows, that full 9 feet, with the structure hidden within the roof slab. The roof itself is a 7-inch concrete slab. It also has some recesses on the corners and ends so that we can hide the transition between the panels and the panel-to-panel connection. But it is a pre-tensioned slab system. So there's steel strands running through there that have been pulled taut at around 130,000 psi and are then going to be cut and released as the forms are stripped to increase the strength and span capacity of that 7-inch concrete panel. Additionally, we have some exterior concrete elements that we're calling gutters. Those gutters are in length between 12 and 6 feet, and they are supported about 10 feet above the ground. They are used to drain water off of the roof, but also are a surface to provide plantings and a hydroponic planting and landscaping system is attached to those. Those are also made with both traditional reinforcing and a mix that does contain a little bit of fiber reinforcing as well.